Well, now we'll find out the equivalent of resistances connected in more complex manner, that is in series parallel, and that usually confuses students. Okay, let us consider one circuit. This is one resistance, another this is one DC voltage source. We have to find out the equivalent resistance between these 2 points. This point A, this point B. Suppose this is 2 ohm, this is 4 ohm, this is 3 ohm, this is 6 ohm. Now you have to calculate the equivalent resistance between these 2 points. What will be the equivalent resistance? You can see that these 2 resistances are connected in parallel, so their equivalent will be how much? You can, if it is RE, okay, then the equivalent circuit will be like this. Let this be RE1, it is RE1, and equivalent of these 2 resistances, these 2 are also connected in parallel. This is suppose point C, so this is point C, and this is point A. Okay, the equivalent of these 2 is, that is RE2. Okay. We have to calculate the equivalent of these 2 resistances connected in parallel, that is RE1, and these 2 resistances are also connected in parallel, that is RE2, and now these 2 resistances are connected in series. Circuit now reduces to simple RE, that is equal to RE1 plus RE2. Okay, this is the equivalent resistance between A and B. Suppose it is 12 volt, then 12 volt divided by RE is the current that is flowing in this main branch. You can calculate RE1. What is RE1? RE1 is equal to 1 divided by RE1, that is equal to 1 by 2 plus 1 by 4. So RE1 is equal to 2 into 4 divided by 2 plus 4. Usually when 2 resistances are there, then you can directly, instead of writing this, you can directly write it as RE1, that is equal to this into this, 2 into 4 divided by this plus this, 2 plus 4. Similarly for these 2 resistances, RE2, that is equal to 3 into 6 divided by 3 plus 6. So you can find out this, you can find out this. Now you can find the sum of this, that is RE. Okay, this is one simple circuit, and similarly if more resistances are connected in series, suppose one more resistance like this is connected in series, so you can connect one resistance here. So in that case RE will be this plus this plus this. This is one more circuit. This is suppose 10 ohm and this is 1 ohm. So what is the equivalent resistance between these 2 points? It is simply 10 ohm. Okay, if I'll say what is the equivalent resistance between these 2 points, that is AB, then what is the equivalent resistance? You can see that this 10 ohm and 1 ohm are connected in series, so you should arrange it in such a way so that it will be easier to find the equivalent resistance. So you can arrange it like this. This is 1 ohm and this resistance is 10 ohm. Okay, now this is our point A and this is point B. So we can find the equivalent resistance between these 2 points by simply adding these 2. Similarly, if I will connect one resistance across this, now I will say what is the equivalent resistance between these 2 points A, B. Let this be 2 ohm. Okay, what is the equivalent resistance? How you can find out? It is somewhat confusing. Actually you can see that this 10 ohm and 2 ohm are in parallel. Okay, these 2 are not in parallel because battery is there. So connecting it here or connecting it here or connecting it here, it does not matter. Okay, so now rearranging this circuit, we can see that this circuit reduces to Okay, so this is A, this is point B, this is 1 ohm, this is 2 ohm, and this is 10 ohm. Now you can see that these two are in parallel. Okay, and you can find out the equivalent, that is 10 into 2 divided by 10 plus 2. Now you can reduce this circuit again like this. Okay, this is point A, this is point B. Now this resistance I have moved to this point. It does not matter whether you keep it here or here. This is the same branch, the same current is flowing through this. Okay, so this is the equivalent of these two resistances in parallel. That is, suppose RE1, this is RE1 and this is 1 ohm. Now you can find the equivalent between these two, that is RE1 plus 1. Let us draw another circuit. This is 3 ohm and this is 6 ohm. Okay, you have to calculate the equivalent resistance between these two terminals AB. Now you can say that these two resistances are in parallel. They are not in parallel. It looks like that. If these two terminals will be connected, then it will be in parallel. That is not the case here. So you can see that these two are in series actually. So this circuit can be reconfigured to this one. This is point A, this is point B. So this is 3 ohm and this is 6 ohm. So these are in series. You can find the equivalent as 9 ohm. This is one more circuit. This is 1 ohm, this is 2 ohm, this is 1 ohm, 1 ohm. Now what is the equivalent resistance between these two terminals? Okay, what is the equivalent resistance? These two are in series, so the equivalent will be 2 ohm. So this circuit reduces to, this is 2 ohm, equivalent of these two, and this is 2 ohm. They are connected in parallel, and this is point A, this is point B, AB. You can find the equivalent of these two, that is 2 into 2 divided by 2 plus 2, that is 1 ohm. So equivalent of these two is 1 ohm, this is 1 ohm. So 1 plus 1, it will be 2 ohm. So between A and B, it is 2 ohm. Okay, let us consider one more circuit. Two resistances, and resistance is connected like this, that is connected like this. Here I am not showing the battery. You have to find out the equivalent resistance between these two terminals. This is 1 ohm, this is 1 ohm, 1 ohm, this is 1 ohm. You have to find out the equivalent resistance. Now you can, first you should identify which resistances are in series and which are in parallel. Okay, so you can merge these 2 points. So merging these 2 points, the circuit will be reduced to this is point A and this is point B. Now by merging this, it in the circuit reduces to this one. So this is the point, junction point. Now these two are in parallel. This is 1 ohm, this is 1 ohm, this is 1 ohm, this is 1 ohm. These two are in parallel, so you can find their equivalent, that is 0.5 ohm, and these two are also in parallel, that is 0.5 ohm. Now these two are in series, So this is 0.5, 0.5. Okay, 0.5, that is the equivalent of these two, and this 0.5 is the equivalent of these two. They are connected in series. Now you can find the equivalent resistance between these 2 points. Maybe. Now let us draw another circuit. That these are all 2 ohm resistances. Find out the equivalent resistance between these 2 terminal points. Here these 2 points are connected by a connecting lead. So these 2 points are at the same potential. So you can merge these 2 points. That is, suppose this is X, Y. They will merge to a single point. Okay. So the circuit will be reduced to merging these 2. So the point will reduce to this is the equivalent circuit. Okay, these 2 points are at the same potential and they will merge to a single point. This point or this point, they are also at the same potential. This is just to for better visualization that we have separated, but these are the same. Now this is 2 into their equivalent is 1 ohm and this 2 equivalent is 1 ohm. So 1 plus 1, it will be 2 ohm. So the equivalent between these 2 is 2 ohm. Similarly, this circuit also can be arranged like this. Okay, this is the equivalent resistance between these 2. This is connected. These 2 are at the same potential. So these 2 will merge at a single point. So these 2 will be in parallel like this, and these 2 will be in parallel. Okay, so you can find the equivalent of this. That will be in series with the equivalent of these 2. These 2 are in parallel. Their equivalent is 1 ohm, and these 2 in parallel. Their equivalent is 1 ohm. Now 1 ohm plus 1 ohm, that is 2 ohm, is the equivalent resistance between A and B. This circuit can be arranged like this, many ways, but you have to reconfigure in such a way so that it will be easier to calculate the equivalent resistance. And if there will be a resistance here instead of suppose there will be a resistance here, then how to calculate the equivalent resistance between these 2? Now it is not easier because you can see that these 2 are not in parallel because there is a resistance here, and also these 2 are not in parallel. In that case, if there is a symmetry, then you can calculate. Okay, but for the general case, it is 2 ohm. This is 3 ohm. This is 4 ohm. And this is 2 ohm, like this. So you have to calculate the equivalent resistance between these 2, A and B, and it is not so easy to calculate. And for that we have to convert this delta connection to the equivalent star connection, or we can inject a voltage across this and solve this circuit and find out the current. What is the current I flowing through the circuit? Then this voltage, suppose this voltage applied is V, then V by I is equal to R. That is the equivalent resistance of this configuration. That way also we can calculate. You can see that these 3 are in delta, and you can convert these 3 are also in delta, but you can convert any of these to star. Equivalent star will be like this. So now these are not here, these 3, and instead there are resistances in star connection. Okay, now you can see that this is in series with this and this is in series with this. The circuit will be like this. This is the star connection. This resistance is this one, and now you can find out the series resistance of these two, okay, and series of these two. Now equivalent of these two are in parallel, and you will find the another equivalent resistance, and that will be in series with this. So that we will calculate, that we will study later, how to find out the equivalent star and delta resistance, that these resistances that you have to find out. Okay, that's all for now. We will discuss more next time.